Hi Handyman's astronomers, this is Julien from the French astronomy club Astrogatine. Welcome back to this new video. I would like to share with you my new rDUINOScope, which is much more compact and it includes more functions and improvements, as well as a new bigger objects catalog. Maybe you remember my first version, which looked like a cup of noodle. So you are looking at the inside of my first build, and we can say that the wiring is not the most reliable we can do. I really wanted to improve the reliability and simplicity of all that, so I built a PCB. So I designed this PCB with the Easy EDA software. I spent time to fine-tune the routings. The goal was to put the maximum of components on the copper plate. I wanted to miniaturize at the maximum the circuit in order to bring it into the smallest box, and indeed to have the best reliability in the connections and the ground, especially for the GPS and the Bluetooth module, which are known to be a little capricious. Here we have the PCB done by a well-known Chinese company. So I sent them the Gerber files and I received a few weeks later the board, which fit perfectly in this box. So we're gonna see now what box it is. So I searched in a bunch of boxes references. My goal was to find the smallest box as I can to put the maximum of components inside it. I tried to make plans on several boxes and stopped to this one where you can see here the reference AKH79. You can see right now the size of this box on the screen, but be careful, there is several references that looks like this one. This is right, the AKH79 for the PCB I made. As you can see, there are several colors and you can choose the one you like. I like the design and there is a flat part for the connectors. And then I used the plans to design the PCB. So you can see here the two boxes side by side. As you can see here, the new box is approximately the same height as the old one, but the new one is much more thinner. The new one is 33 millimeters when the old one was 55. It is also narrower and fits better in the hand. Let's take a look at the software part now. I started with the rDUINO version, the one with the new interface. This interface was created by him and I found it really excellent. And we're gonna see later I've added new functions, I've corrected bugs, and I've had to remove some modules to let it fit all in the box. So I've not removed a lot of things, but it was really necessary. I've removed the focuser because I could not afford to put a third driver on the box, couldn't fit. There was also two 5V plugs to feed the fans. So I've removed the one and keep the other one to activate an internal fan in order to cooling the inside of the box. All the other stuff are inside the box. You have the Bluetooth, you have the GPS, the big joystick and the auto guiding function. So we take a look now at the box. On the front you have the joystick and the 3.5-inch screen. On the rear side you have the fan and you have the power plug on the bottom. Here we have a look on the top. There is two RJ45 connectors for the motors, one RJ12 for the auto guiding. You have a full access of the USB connectors of the Arduino DUI. If you want to flash a new firmware, you can connect it on the computer. Here we have the grid of the 20mm fan to cooling the box. On the top left you have a grid for the DHT22 and you have a red button to put the screen in night mode. On the right side I made a little hole to see the status LED on the GPS board. So you were waiting for it, let's power up this rDUINOScope and take a look at the functions. We can see the boot up is faster than before. There is no more catalog loaded at the start. There is only tested because there is much more catalogs than before. I had to be tricky because there is very little memory on this board. Now the catalogs are loaded when you use it and the memory is released when you leave it. The previous GPS and this element page are the same as before. So let's continue and we take a look now what's changed. We can see here there is temperature and humidity like before. I previously added the dew point, which is implemented now in the Collinder code. There was also another bug here on the meridian flip status. Both information here, auto and off, were superimposed. There was a mistake in the code, so I've corrected it. There was also an error for the local sidereal time for France because you have a shift of 1 hour for winter and 2 hours for the summertime. I've corrected it for my country, so you can take a look for yours. We can see here the bottom menu is the same as before. Let's tap on this menu to see the second menu with the changes I've made. You can see now on the right you have a fan for cooling the box. When you tap on it, it activates the little fan on the rear of the box to push some fresh air inside it. And you can see on the bottom a new button with a store position function. When you tap on it, it stores the actual position of the telescope. Once done, you can see a button go to stored position. You now be able to put the position in memory and go to back. It can be useful, for example, when you are doing astrophotography and you had a good framing but you lost the focus. Then you can store and go to a bright star to focusing and go to back. Let's take a look at the options. You may have seen that there was a T-calibrate function that was not activated, so I made a new function to calibrate the screen because I had a little shift on my touch screen. In this function, you tap each corner several times until a green square appears and it stores curves of calibration data and correct for all the interface. Calibration data is stored in the SD card. So now let's take a look at the catalogs. We tap on the load button and we can see now we have a new wallpaper with the pillars of the creation from the James Webb Telescope, which is pretty cool. We can see the arrangement is different than before, and we can see two new buttons. Here we have the previous and the next catalog. So the first catalog is the solar system, then we have a bright star catalog for focusing purpose, then we have the double stars catalog, a variable star catalog. If I tap on the next catalog here, then we have the deep sky objects. So the first one is the Messier catalog, then we have the new general catalog divided in 5 parts sorted by magnitude. So this is very useful because depending on your telescope diameter, you can choose the appropriate catalogs. All these objects are for Northern Hemisphere, and here we have the index catalog where I've put all the objects from this catalog which are not in NGC catalog, and then we have the custom catalog where I put the Collinder objects for Northern Hemisphere and some special objects such as black holes, binary systems and giant stars and some of the brightest quasars. So there is approximately 3000 objects in this database and I've deleted all double entries. As you can see, I've sorted the objects by constellation and we can see now also the magnitude and the constellation on the button. I found that very useful because you have a direct view on the magnitude of each object, and this is very useful to group the object by constellation when you are doing GoTo to minimize the slow time. So we're gonna go back to the previous menu and we see here the solar system that you know. Then we have 172 bright stars to using with the batting off. Then we have a double stars catalog with 160 stars with the name, the constellation and the magnitude. We have a variable stars catalog with the name, the constellation and the magnitude of the stars. Then we have the Messier catalog, which is unlike the others sorted by the name. You've also the magnitude and the constellation. I would like to show you something interesting. If I go to on a double star, we have here information about the star's color. Here we have a double with the yellow and the blue star, and bottom here we have all the other information such as magnitude and the separation. And this is the same for the variable stars. If I go to here on a variable star, we have here informations about the variable type, the constellation, the magnitude, min and max, and the period. So I've modified the code to integrate these new catalogs, and I integrated pages for each catalog. So if you browse a catalog, select an object, go to another catalog, then select another object, etc. If you go back to a catalog that you have previously browsed, you're gonna find it on exactly the same page as when you have left it. You should know that in each part of the NGC catalog you have 480 objects, and this is very useful to find the page as we left it. And at any moment you can push this red button to put the rDUINOScope in night mode. I've also modified the auto-guiding screen to remove kind of circles that were non-functional. Now we're gonna talk about the construction because there are a few things to follow to get everything out of the box. The first thing I did is to take my PCB and solder all the JST connectors. Then I soldered all the other components like transistor, capacitors, resistors, etc. And then I worked on the joystick. On the design I had the possibility to put it like that, and there was also the possibility to put it behind like this, because I didn't know during the design if the height was suitable. So I soldered here a 5-wire GST connector in 1.25 on this joystick. So I continue with the screen. I soldered like that two ZH1.5 connectors. Both are 8 wires, and you have on the board the pinout screen ground to cord CS. So we have here the GPS module with the 5-wire GST connector in 1.25. So to put my PCB on this Arduino board, you have to unsolder the power connector, which is quite easy to remove. So we have to remove the metal pin from this plastic. This is mandatory. We have to save 2 mm, otherwise the stack will not fit in the box. So I've put all the metal pins on this Arduino. So here we have the stack, and we can see that it fits perfectly. You can see some Arduino pin that almost touch the PCB. We can see that it fits very well, and we can see the two CMS capacitors here. These capacitors are meant to protect the drivers. They are quite easy to solder. I've not detailed the process. You can see here a whole rectangle shape. This is for the RTC module, which is very thick. I had to make this rectangle in the design to make its insertion possible. Here you have a first test of fit in box. You're gonna see in this video that the very all fits to the millimeter. It seems that this box was made for the rDUINOScope. The screen will fit like this, so the circular hole for the fixation will be just behind the plastic cylinders. So let's talk about the RJ45 connectors. They have just the right height. If I put them just like this on the board, it's aligned with the top of the box and the two parts are on the same plane. You have just the place to fit the lid, and the screen will be plated on the RJ45 connectors with almost no place between the screen and these connectors. Next, I worked with the drivers. I had to remove the default pins to reduce the height, so I've replaced these default pins by shorter ones. The pins used are this one. These pins are normally meant to be used for the RGB in PCs. The female pins are shorter, and I've removed the plastic on the male pins, and I've cut the male pins to fit on the drivers. So we have here the drivers placed on the board, and we have here a system that is extra flat. It will not interfere with the installation of the screen. And now the drivers are socketed, so you can remove it in case of fail to replace them. Here I show you the height. If I hadn't removed the original pins, the drivers would have been approximately at this height. So now let's install the RTC module, and we have to shorten these 4 pins to not interfere with the header. So you can see here on the battery holder there is a little space. I have to unsolder it to remove it. So the RTC module will be placed like this. So you can see the space to place it is very thin because of the components you have behind. So you can see here the header legs are a little short and I have to bend the RTC pins to let it fit horizontally in the rectangle hole. And you can see here unsoldered and soldered again the battery holder, so to remove the little space, and I've bent the 4 pins for the RTC module to let it fit on the main board. So now you have to solder the 4 pins that goes in the Arduino board and the 4 pins of the RTC header. You have to do that in that order, don't get the order wrong. So now I've soldered the MISO, the MOSI, the SCK with this female DuPont cable. Just have to solder it on the board and plug it in the Arduino. So here we have the 3 wires soldered on the board. So here I've soldered the driver holders and you can see the CMS capacitors. We have to do a little modification on the RJ12 connector. It is 1.5 mm taller than the RJ45. To do that, first I've cut the part H-shaped below the connector, which gives us a half millimeter less. So you can see here on the right the modified connector. So with doing that, we've recovered about a half of a millimeter, and it will be placed a little lower on the board. So I'll let you see now the difference in the plastic box you have on the right, the modified connector. But we have to cut the back part of this connector and let 4.5 mm in front of it to let the little lock on the cable to fit correctly. The cutted back part will let fit the screen. Here we have the connector finally modified, and we can see we can plug the cable without any issue. So now we have to solder this GST 1.25 connector with 3 wires in this order for the DHT22. And here we have the job done. Here we have the day-night switch with the JST 1.25. The same JST on the speaker. We have now to make the bridge. There is a bridge on the board. So to do that, we take 2 JST 1.25 in 5 wires and you solder it color by color. Then here we go with the Bluetooth module, which is plugged behind the board. You have to remove all the pins on the Bluetooth module to place it on the header like this. You have to put the pins on the Bluetooth module on the other side to place it correctly. Here we have the pins soldered on the other side and we can plug it right there, and this is very thin. I've used Kapton in several places to avoid shortcuts. Kapton on the cable legs to protect the Bluetooth module and on the other side to protect the 5V buck. Then I soldered the 5V buck on the top of the board by using some tinned wires. Here we have the result with the Bluetooth module on the side and the 5V buck on the other side. To let you see the optimization of all that, I'll let you see the height of the 5V buck in the box. So I soldered the 2 RJ45 connectors and the RJ12 connector. I've put a little band of Kapton on the Arduino DUI to avoid any contact with the battery on the RTC module. And you can see I've soldered all the pins from the Arduino DUI to the main board. Then I used my hot air iron to squeeze all the heat-shrink sleeves I've placed in several modules. So I've plugged all the modules we have here, the MISO, MOSI, SCK wires, the bridge here, because I hadn't enough place to make the track. We have the GPS module, the day-night switch, We have the DHT22, the speaker, and here below the internal fan remains to be connected. So I've boot the system for the first time without the motors, and I saw that it worked right. So the first very important thing to do before plugging the motors is to set the amperage of the drivers. So here we measure a voltage between the potentiometer of the driver and the ground, and we have to lower the value. Here by default the voltage was at the maximum about 185 volts. On my first version I was at 0.65 volts, so I'm gonna set it at the same value. So the multimeter black wire is on the ground of the buck, and the red wire is connected on the screwdriver that I put on the potentiometer on the driver. So to know how to set your drivers, you take a max amperage for your motor. On mine this is 1.68. You take this value and you divide it by 2, and when you set it as a voltage you have the right value for the amps on your motors. This is the maximum values, but you can lower it. On mine I lowered from 0.84 to 0.65. That reduced the torque, but it works correctly. And then the driver hit less and no more heatsink is needed. And it lowers also the electric consumption, very useful when you are on batteries. So here we have the first test with the motors plugged, and the rDUINOScope is on tracking right now. So I've put an aluminum plate I had on my previous version to cooling the 7809 MOSFET, which is heat a lot, and I've put bands of Kapton to protect the circuit, which is directly below. So here I started to cut the box. I've cut a rectangle for the RJ connectors and the 2 USB connectors for the Arduino board. On the left side I've cut a part to integrate the DHT22. And I've cut a place for the GPS antenna. Take a look at the height of this antenna and the height of the box. This is exactly the same height. I say it to you, this box was waiting for the rDUINOScope. It was made for it. Here we have the box with the lateral cut finished. And if I put the lid on the box, you're gonna see one more time that all fits very well. We can see a very little space between the RJ connectors and the top of the lid, just the space for the screen. I'm very happy because I spent a lot of time to make plans on the paper sheet to be sure all fit in the box, and indeed at the end when you have the box in the hand all fits well. So for the GPS antenna I've cut the lid like that, and same for the RJ connectors, I've cut the lid like that. For the screen it will be like that, so we have to cut a little bit the 2 cylinders here to put correctly the screen. On the lid part we have to cut these 2 plastic parts. So I used the drill to remove that. This part of the lid will be very flat. And then I started to cut a big rectangle for the screen. And that was a little bit hard to remove. The plastic is very thick and cut it with a cutter take quite a time. I've also had to cut this little part here to put correctly the screen. And we can see that when the cut is finished, that the screen will fit perfectly in the lid. I've drilled the 4 holes to attach the screen. I've put the GPS board and the antenna with a little angle. It's on purpose to detect satellites when on vertical position. I've drilled a hole to see the GPS status LED and also on the green plastic. Here we have the best place to put the power connector, but it is not quite easy to fit. That was a little complicated, but I've managed to fit the nut. Here we have a 25mm hole for the joystick, driller with hole saw, 18.5mm hole for the rear fan, a square hole for the switch, and little holes for the DHT22. Here we have the switch in place, and I've put some double-sided tape to put the speaker just behind the DHT22. I had to remove this plastic here because we can't remove the micro SD card. If we put the lid on the box, we can see it finished right in front the side of the lid. The screen will almost touch the RJ45 connectors. And also I had to cut the cylinder on the box side here to put correctly the screen and the lid. Here we have the 20mm fan in 5 volts, which is plugged on a GST 1.25 connector. I've put Captain on the screen where it's touched the RJ45 connectors and to maintain the wires. I've put hot glue on several places to prevent unsoldering. On my design there is rectangles just behind the driver's chip. They are meant to put thermal pads. These rectangles are connected to the ground, which is a big copper plate, and then I use it like a heatsink to dissipate the heat by below. So we have the drivers placed with the thermal pads below. The final step are to plug the modules and the screen to close the box. So we have here the connector for the fan, the connector for the speaker, the DHT22, we have the day-night switch. So here we have all the modules plugged, and stir the PCB with 12mm screw by 2.5. So here we go, I've stirred the GPS PCB with double-sided tape. So here we have the detail of the GPS antenna, and check that it can detect satellites in vertical position. Now the screen is plugged and we have to close the box. You can see the power connector. This was the most difficult part of the construction. The drivers. The little dedication to the astrogating club in France, which I am a member. I am sure that it will please to Christophe, the boss. Here we have the optocouplers for the auto guiding. It is much more clean and there is much less wires than the previous version. Here we have the 5 volts buck and the Adafruit screen 3.5 inch. So this is the end of this video. I hope you enjoyed it and I hope that it will make you want to make your own. I hope that the PCB I made and the new fader and the new object database and the modernization of this rDUINOScope will make as many people as possible to want to keep the project going, because it is a great project. Thanks to you and good skies.